Mathematica is renowned as the world's ultimate environment for computation, but let's take a look at some of the basic types of calculations that are possible and how intuitive it is to compute just about anything in Mathematica. So let's make a new section. Again, you can use the cell insertion assistant or the format menu or a keyboard shortcut. Let's call this section Basic Calculations. And then let's make a new subsection, and we'll call that Exact versus Approximate Calculations. As we saw in the previous video, Mathematica will always give you the most exact answer possible. For example, let's take 224 divided by 24,248, and we'll evaluate that calculation. We'll get a result of 4 over 433. This is the exact representation of this quantity, and it is reduced as much as possible, which is great. No other work needed on our part to get that simplest possible representation. But perhaps I want the numerical approximation of that result instead. I can use a command called in to do that. While almost all Mathematica commands are full words, in is one of the few exceptions because it just gets used so often. So I'm going to mouse down and start a new input cell. I'll type in, and then I put in my pair of square brackets, and finally I put in what I want to approximate. In this case, I'm going to copy and paste 4 over 433. When I evaluate with Shift-Enter, then I get a numerical result. I can also give in a second argument, which is the number of digits I want to approximate. So let's put in our second argument by adding a comma to separate what I want to approximate and the number of digits I want to in my approximation, and I'm going to approximate to 100 digits. When I reevaluate, I get a much longer approximation. So let's look at another example of exact computation within Mathematica. Let's open that Classroom Assistant palette again from the Palettes menu. We'll go to the Basic Commands section. We'll choose Matrix Commands tab. Now from here, let's insert a 2x2 matrix by clicking the icon and filling in the entries as 6, and then you can tab to jump to the next placeholder, 6, 1, and 5, and then hit Shift-Enter to evaluate. When I evaluate, I see that my result is a list of lists. In this case, a list containing 6 and 6, and another list containing 1 and 5. That's because in Mathematica, matrices are simply lists of lists. So in this particular case, Mathematica just says, yep, you entered a matrix, and here it is. Okay, so now that let's look at how we can create variable assignments to store the results of operations. Let's create a new subsection called variable assignment, and then use the down arrow key to start a new input cell. And here we are going to create a variable named A and give it a value of 224 over 24,248. We do this by entering A equals 224 divided by 24,248. And evaluating the result. Now, if I enter in A and evaluate it, I get back 4 over 433. I can use A in any command I want now. For example, let's square A. Going back to the palette, I'm going to go to the calculator section and choose the icon for superscript, which pastes in a template, and I'm going to enter in A to the second power as another option. Remember, you can use tab to jump to the next placeholder in one of these templates to get that result. You can also enter this two-dimensional expression of a squared by entering in A and then hitting Control-6 on your keyboard. This keyboard shortcut is displayed when you mouse over the icon in the palette. And it's easy to remember since the caret, which is used to indicate exponentiation, is above the 6 on the keyboard as well. There are lots of other easy-to-remember shortcuts for entering in input, like Control fraction sign will give you a 2D fractional input, and Control-2 will give you a square root symbol. You can also find a complete listing in the documentation by searching for keyboard shortcuts. Now that I have defined A to be a specific value, it's important to remember that definition, because if I do something like expand, open square bracket, and then parentheses A plus B to the third power, and close that square bracket, the result I get automatically substitutes in the specific value I defined for A. If I want to throw away the variable assignment, I can do that then by using the clear command. So let's evaluate clear of A. And we can test that it's really gone by reevaluating that expand command, which now returns a purely symbolic result, since I do not have any variable assignments for A or B in my Mathematica session. Okay, so let's move on to defining our own function. First, let's create a new subsection, and we'll call this one creating functions. Now let's make a new input cell, and we are going to enter in f open square bracket x underscore and then close square bracket. The square brackets mean that they will surround our function arguments, and the f will be our function's name. Now, if you remember earlier, I said that Wolfram language commands are capitalized, and that's true for all the Wolfram language commands in Mathematica itself. That's not to say that you cannot capitalize the names of any functions you create, because you can, but I always like to give my functions lowercase names because that makes it much easier on me or my colleagues to tell what are functions that I've defined versus what are built-in Wolfram language commands. Okay, so let's continue with our function definition. The next part we want to enter is colon equals, using the colon sign and then the equal sign. And that means our function is going to use delayed assignment, which is what you usually want to do with your functions, but you can read more about this topic in the documentation if it interests you. Now on the right-hand side, I have to tell Mathematica what I want this function to do. So let's make our function return the expression x squared plus 2x plus 1. So we enter that in. I'm going to use keyboard shortcuts to typeset the exponent. But you can use the caret to input this as 1D input, or you can use the palettes to get the typeset template if you want. Now that our function is defined, we need to hit Shift-Enter to evaluate it. We don't get a result when we evaluate it because all we have done at this point is to define our function. We haven't invoked it to do anything just yet. So let's use our function to do something. When we defined it, you'll notice the underscore character that was tacked on to the function argument x. This told Mathematica that I didn't want to reserve x specifically for my function, but rather that x was sort of a placeholder for me to fill in with values later on. This means that we can use our f function with all sorts of different types of arguments. So let's try it out. For example, we can pass the value 5 to our function by evaluating f of 5. Let's try f of 5.5. And when we do that, we get a result of 42.25. So our function works with any type of input, which is really useful. Let's try a different type of argument. In Mathematica, if you have some text inside of a pair of quotation marks, that is referred to as a string. If we pass a string to our function, like asking for the result of f of, quotes, dog, we see that dog gets slotted in for the placeholder, and we get a result of 1 plus 2 times dog plus dog squared. So far during this video, we have seen that the single equal sign is used for variable assignment, and then colon equal sign is used when defining functions. There's also one more really important type of equal sign to learn, and that is the double equal sign. And it's used when you are solving equations. There are different types of solving commands in Mathematica, but one of the most commonly used versions is, coincidentally enough, named solve. So let's use it to solve for the roots of a polynomial. We type in solve, and we can then use the command completion menus to create a template of what we need to fill in, which is basically some expression that we are trying to solve, and then the variable or list of variables that we want to solve for. In this case, let's enter in the canonical quadratic formula equation. We start by typing in A, and then I want to pause here and say that you can either press space and then type x squared, or you can type A and then put in an asterisk to indicate multiplication and then x squared. But what you can't do is type in ax squared without either a space or an explicit asterisk, because Mathematica will not recognize that the a and x are separate symbols. So when you use the asterisk, which is explicit multiplication, or use the space, which is implied multiplication, then Mathematica recognizes that those are different symbols and will treat them differently, which is what we want for this example. Okay, so continuing on our expression, we can then enter in b space x for b times x plus c equals 0. And this is important because you will notice when here we use the double equal sign. The double equal sign stands for testing equality, so you need to use it in situations where you are entering an equation and only use the single equal sign when defining a variable. Now, for the last part, we just need to enter in x, since that's the only variable that we are solving for, and we evaluate using Shift-Enter to get the results that we all learned from our school days. We can also use our own function with commands like solve. So let's try solve of f of x equals 36 and solve for x. And we will see that either x equals 5 or x equals -7, which both satisfy the equation. Now that we've covered variable assignments and function definitions, we'll move on to look at how to create and customize 2D and 3D graphics in Mathematica.